Good evening, everyone. I'm Hidhay, Managing Director of. I think,
Sir,
is
it
my
is
screen
not.
visible?
Sir, it is not getting to the full screen, sir. Varun, can you confirm from? Yeah, yes, sir. Now it is fine, sir. It is on full screen. Yeah, we can go ahead, sir.
Fine. So, good evening, everyone. I'm Hidhay, Managing Director of Systel Group of Companies. So, we are an Indo Danish company formed in the year 2002 with a vision to simplify compressed air management. So, in the last 18 years of our operation, we have improved over 1,600 compressed air systems across Asia Pacific. And all these projects has resulted in a combined energy saving of over 50 million megawatt hours in compressed air systems alone. And we were the first company in Asia Pacific to be certified under ISO 11011, which is the governing standard for compressed air assessment and management. And we are also the first company to introduce Industry 5.0 for compressed air systems in the Indian market. So we know that throughout the life cycle cost of a compressor, energy forms a major chunk of it. More than 76% of the cost is spent towards energy, and capital and maintenance cost hardly remain 12% each. But what we may not be aware about is throughout the running a 100 HP compressor in a year would consume close to 648,000 kilowatt hours and wasting as much as 100 tons of greenhouse gas emissions. And it would, if it is a water-cooled compressor, then this 100 HP compressor might require around 5.1 million liters for its cooling requirement. And this compressor would produce close to 104,000 liters of condensate. And the compressors generate almost like 50% of the input energy in the form of heat. So a 100 HP compressor will generate close to 254,000 bitumen hours of heat energy. Compressed air systems, as we might be knowing, that like it is one of the most inefficient utilities, since almost like 70 to 80% of the input energy is wasted in the various forms, like heat loss contribute somewhere between 40 to 50%, leakages somewhere between 20 to 30%, artificial demand, misuses, and distribution losses. So hardly 10 to 15% of the input energy gets converted into a usable form and reaches the end point of use. So though compressed air is a very high cost intensive utility, there are a lot of puzzles that many users don't understand with it, like how much air is actually produced, because there is a big misunderstanding when it comes to the compressor's rated capacities, like what you assume as a capacity and what the manufacturer claims to be the capacity are completely two different terms. So usually, there is many of the cases the industrial users, especially the MSME users, might be clueless about how much air is actually produced in the system, and they might not also have a clear idea about what is the actual requirement. Consumption and requirements are two different terms. So unless you know what is the actual requirement and what is the actual air produced, you might be not knowing about what is the losses that your system experiences. So that goes with the third puzzle of understanding what is the actual losses the system experiences and what are the equipment efficiencies. So when we don't have answers for these four puzzles, so our system is usually running inefficient. So this will create high energy cost, high maintenance cost in terms of increased wear and tear due to higher operation hours of compressors and allied equipments, heavy leakages, frequent breakdowns, poor air quality, and also production interruptions in case if the process is very sensitive to a stable air quality and stable system pressure. So in overall, when we don't know how much air we produce, what is the actual requirement, how much we consume, what are the different form of losses that the facility incurs, we will be ending up with a higher cost of ownership. So with Industry 5.0 solutions, we try to help you out to raise above the present energy cost wastages, your high greenhouse gas emissions, to higher operational efficiency and lower over cost of ownership. So this we try to do with the systematic and smart improvements. So we deploy Industry 5.0 for compressed air systems with the objective of moving from wastefulness to wastelessness. So what is Industry 5.0? So Industry 5.0 refers to people working alongside smart technology and smart machines. So it's about the smart technology helping humans to work in a much faster and better way by leveraging advanced techniques like Internet of Things and big data. And it also adds a personal touch to the Industry 4.0 pillars of automation and efficiency. So the objective of Industry 4.0 is to interconnect machines and systems for maximum performance optimization, whereas Industry 5.0 takes such efficiency and productivity a step further. So it's about refining the collaborative interactions between humans and machines. So Industry 5.0 is basically aimed at supporting and not superseding humans. Industry 5.0 is also about finding an optimal balance of efficiency and productivity. So with many of the industries migrating towards Industry 5.0, the growth of Industry 5.0, even with the MSME sector, will be unavoidable in the future. So the first process with Industry 5.0 is to start doing a baseline of your operating conditions. So we start with measuring what is the power input the compressor draws in to produce a unit of compressed air. So this we do it with our smart IoT based power meters, which transmit the data in real time to our smart monitoring software. And we also have a petrotip flow sensor that's been fixed on the compressor output. So these measurements happen on a real time to understand what is the specific energy efficiency of the compressors. And with our smart pressure sensors, you can measure what is the pressure drop that your system is experiencing across the treatment equipments like filters and dryers, and a pressure dew point sensor to indicate what is the amount of moisture content or what is the amount of pressure dew point that your dryer is capable of achieving and delivering to the downstream of the system. A thermal mass flow sensor to indicate what is the consumption that is happening on the production header levels. And on the demand side, like we have thermal mass flow sensors deployed at the production department and also at the machine level. So they collect real-time data about what is the leakages the machines or your production process are experiencing. They also keep a track and understand what is the artificial demand that your system experiences. Artificial demand is a term referred to any excess consumption because of having unregulated pressure zones. So usually artificial demand is in the range of 5 to 10%, and the demand side optimization also collects data about the misuses that is happening across your system. Then the second step of Industry 5.0 is like we go with custom with user specific goals. So we define what is the system efficiency. This talks about what is the kilowatt your entire compressed air supply side of the system consumes to produce a unit of air. So for the best, for the best standard, we recommend not to exceed a specific overall system efficiency of 0.17 kW per CFM. And at the compressors, it's always better. Like when you're running a screw compressor, do not exceed a specific power of 0.155 or 0.16 kW per CFM. And maintaining a pressure dew point in case of a refrigerant dryer at less than 3 degrees CTD, or for the desiccant dryer at minus 50 degree, will be a key to avoid any recurrence of leakages, because leakages are not a problem on their own. They are symptom of a problem in the system. So when there is very excessive moisture contamination in your system, they create rusting, scaling in your pipelines. They also damage the O-rings or seals of your pneumatic components, so provoking new leaks. So maintaining a pressure dew point at these levels will help you to ensure that your system doesn't have excessive losses due to leakages. And maintaining pressures, with maintaining the system with minimal pressure drop. And ideally designed, the system should not exceed a pressure drop of 0.5 bar from the compressor discharge to the farthest point of the system. And leakages, like maintaining the leakages at less than 5% of the generation is highly recommendable. And maintaining dual pressure zones for different pressure applications, like Akshay was mentioning, that like avoiding the use of PRV valves and instead going for dual pressure zones, wherein you maintain high and low pressure for your pressure for your different pressure requirements. So we defined these 5 goals, which is basically specific to your industry and your applications. And then we also help you out in implementing the corrections. Like we offer a host of services like leak surveys, leak repairs, measurements, like both temporary and permanent measurements. We also do annual maintenance contracts. We do train your teams for best practices. We can also design a greenfield project, or we can also redesign your existing facilities. We conduct baseline audits. We conduct a performance validations for a variety of equipments like compressors, dryers, your air treatment equipments. We also make sure whether the air quality conforms to ISO 8573 standards. And yeah, so this is the third part of our Industry 5.0 offering. After defining the baseline and defining the goals, we help you in implementing all the corrective actions here. And with the deployment of our smart monitoring system, like we keep a track of your key performance indicators. So this is a dashboard view which gives you an complete insight of what is happening across your compressed air systems, both in terms of trending graphs and also in terms of like speedo charts. So you get an indication of what is the core, what is the consumption that's happening in real time, and what is the power, what is the consumption in terms of power, and what is the overall system efficiency, and what is the cost that you are incurring for running your compressed air system. And with our smart monitoring system, you also get an automated reports, which gives you a snapshot view of the consumption parameters of your compressed air system. So with this, like I would like to go over a very brief case study. So this is a case study about India's, I would say like India's first specialty steel plant. So this plant is based in Tamil Nadu. So we started deploying Industry 5.0 solutions at this plant with an objective of achieving an energy saving of close to 17.5%. This particular end user was very conscious about the environmental and sustainability norms. So they were very particular that they need to save or reduce the greenhouse gas emissions here. So the second objective of the project was to reduce greenhouse gas emissions by up to 3,162 tons. And by reducing this 3,162 tons of carbon emissions, it is equivalent of planting 15,811 fully grown trees. And overall, in terms of cost benefits, like the project was aimed to deliver an energy saving of up to 2.32 crores per annum. So there was a five-step process towards this. Like we started installing the smart monitoring. So wherein we deployed our smart IoT sensors for measuring flow, power, pressure, dew point, and overall system efficiency. And once the sensors they started collecting the data, we did an extensive assessment on the baselines. So we defined the operating baselines for the entire equipments of the compressed air system verticals, and also for the different production departments, and also on the machine level points. And once the baselines were defined, once the gaps were identified, we also implemented corrective actions like leak repairs by eliminating artificial demand, misuses, improving the supply side efficiency. And these actions have resulted in energy savings and reducing the footprints. So here, as you could see, like they were running centrifugal compressors. So as you know that all the centrifugal compressors are equipped with the orifice plate flow sensors. So these sensors basically are integrated. The measurement of these orifice plate flow sensors are directly integrated into the compressor's control panel. So when we measured the pressure drop across this particular orifice plate flow meter, it was observed that they were losing close to 46 kilowatts per hour just for measurement of flow alone with this orifice plate flow meters. So this was they had 3 compressor combinations with a total capacity of around 14,700 CFM. So this has resulted in an energy loss of up to 1,100 kilowatt hours per day. So we replaced all this orifice plate flow meters with our insertion type of protective flow smart flow sensors. So these flow sensors are, since they are of insertion type, they do not induce any pressure drop in the system. So the return on investment for installing these sensors was hardly 83 days, or just under 3 months. So this is a typical application of a pitot or insertion type of flow sensors. And the second point that we concentrated was on the dew point side. Like all the refrigerant dryers that you have, they show an indication of a particular value, which normally the user wrongly interprets as a pressure dew point, but it is the indication that you see here, the 3 degrees that you see here is basically an indication of your evaporative chiller temperature, and this is not the pressure dew point. So at a 3-degree evaporative chiller temperature, your actual pressure dew point is somewhere between 18 degrees PDP, which means that like you are permitting close to 250 grams of moisture for every kilogram of air that's been sent on the downstream of the system. So once we identified that the dryers were having a very high dew point, so we were able to relate that to the huge leakage levels the facility was experiencing. So they had a leakage level of 750 CFM, and the biggest problem with this facility was like though they had an internal maintenance team who very periodically look into the leaks and conduct leak surveys and repair it, still they were experiencing reoccurrence of leaks. So once the dew point issue was addressed here by installing our pressure dew point sensors, which used to alert the users in case if the pressure dew point is high above or reaches above the threshold point. So the user was able to immediately rectify the issues or look into the issues in the dryers. So this prevented the recurrence of leaks, and even after a year or so, the leakage level, the recurrence leakage level has drastically reduced by over 70%. So the investment for this 205 pressure dew point sensors and the return on the ROI calculation was just under 27 days. So when it comes to compressed air systems, nothing could pay you as fast as investing on a proper pressure dew point sensor. And on the department or on the end user level, like there were so many vertex kind of flow sensors that was fixed inline on the pipeline. So these sensors were also inducing pressure drops of around 0.2 bars across the system. So these were all completely replaced with our insertion type of flow sensors. So the pressure drops were completely removed, and this particular facility was also having a department which was very sensitive to pressure fluctuations. So they have to run the compressors at a very elevated pressure level to meet out this pressure drops and pressure fluctuations. So there was a total of around 21 vertex flow sensors in the pipelines, which was creating a pressure drop of up to 1 bar in the system. So by replacing all these flow sensors with our smart insertion type of thermal mass flow sensors, we were able to reduce the consumptions by around 1,862 kilowatt hours per day. So the payback for this particular exercise was just under 9 months. So this is my last slide here. So in overall, the facility enjoyed saving of around 2.5% by avoiding pressure fluctuations, another 2.5% by avoiding leak losses, 5% by having a reduced artificial demand, and around 7.5% by improving the supply side efficiency. So the overall system efficiency has improved from earlier 0.21 kilowatt per CFM to around 0.19 kilowatt per CFM. So this has resulted in an energy saving of around 2.32 crores in a year. So the overall return on investment for this project was less than 6 months. So you can contact us for any more details about Industry 5.0 in the given numbers here. Thank you CAA and WRI team for giving us this opportunity for presenting our views about Industry 5.0 and the benefit that it can pass to the MSME sector. Over to you, Atik.